get started talking about inequalities. Today's just going to kind of be your basics of inequalities. Now, when we're solving inequalities, for the most part, guys, it's the exact same as solving an equation. There's really not a whole lot of differences. There's a couple of huge differences, but really, for the most part, it's the same steps as solving an equation. Now, one thing that is really different with inequalities as opposed to equations, we never graphed the solution to the equation. So whenever I got an answer x equals 5, we never graphed that because the answer is 5. And that's it, just 5, okay? So you didn't need to graph it because you know what 5 is. It's a number, it's right there, it's 5. But an inequality might be something like x is greater than or equal to 5. So x could be 5, but it could also be 6 or 7 or 10 or 20. There's a whole bunch of numbers it could be. And sometimes it's hard to think about all of those, so we like to graph our solutions so we can see our answers. Okay? So the first thing we're going to talk about is how to graph an inequality. Now, there are 4 inequalities, so this is going to be on the inside of that first flap there. Okay? Our first inequality that hopefully you're at least somewhat familiar with is the less than inequality. Now, I don't know about you guys. I know whenever I did, I'm pretty sure it's 4th grade, I will always remember this, and I had to miss recess because I could not remember which one was less than and which one was greater than. It was terrifying. It like scarred me for life. Okay? And then somebody told me the less than looks like an L, and I was like, why didn't my 4th grade teacher tell me that? I wouldn't have had to miss recess. But anyway, so if you have a hard time like just reading it, and I always understood that like the bigger end goes towards the bigger number. But, like, actually reading it, x is less than 0, it looks like an L. Okay, that's the less than. The other one is going to be the greater than. So, x is less than 0. So, what you want to do to graph all of the numbers that are less than 0, you're going to graph them on a number line. So, on your number line, we show where 0 is. Okay? And we're going to show our solutions by shading the numbers that x could be. So if I think about all the numbers less than 0, it's all the negative numbers, right? And all the negative numbers are over here to the left of 0. So I would shade all of these numbers. So the first thing you have to decide when graphing inequalities is if you're going to shade to the left or to the right. The second thing you have to decide is what kind of dot you're going to put in your number. There's 2 options. You could have an open dot or you could have a closed dot. Now the whole idea behind graphing inequalities is you shade what your answer can be. Now, if x is less than 0, this is saying x has to be less than 0. X can't be 0. 0 is not less than 0. It has to be less than 0. So 0 is not included. So what happens is I don't want to shade in 0. So I would use an open dot. Okay, if I were to flip that sign around and look at the greater than sign, more than, bigger than, whatever you want to think of this as, it's going to look like almost the exact same thing. If x is greater than 0, all of the numbers greater than, more than 0 are all the positive numbers, right? So you would shade all of these numbers to the right of 0. And then kind of the same thing. To decide what kind of dot you would use, you would have to decide if 0 is part of your solution set or not. Well, if x has to be greater than 0, it has to be bigger than 0. It can't be 0. It's got to be bigger than 0. So it's the same thing. 0 is not part of your solution set, so you would not shade in the dot at 0. Now, if I look at the other 2, it's almost the exact same thing, except this is less than or equal to. So it could be less than, or it could be equal to. So if x is less than or equal to 0, it means that x could be any number that's less than 0, so any one of these negative numbers. But this time, it could also be 0. So the only thing that changes is my dot is going to be shaded in. It's going to be a closed dot. And then the same thing with the greater than or equal to. Okay? If it is greater than or equal to, the greater than numbers are the numbers to the right. But it also could be equal to 0. So to show that, I would do a closed dot at 0, and that would tell me by looking at the graph that it could be 0 or any of these numbers here. Okay? So the graphing, really pretty simple. Decide what kind of dot, okay? What you're going to find out is that if it's an equal to, you got to have a closed dot. Okay? If it doesn't have an equal to, it's going to be an open dot. and then which side you're going to shape. Okay? Now, the same properties that we used for equations, we can use similar properties for inequalities. And actually, I have a typo here. Should have fixed it last year. Obviously didn't. We have what's called the addition property of inequality and the subtraction property of inequality. The addition property of equality says you can add the same number to both sides of an equation and it won't change your result. The addition property of inequality says you can add the same number to both sides of an inequality and it won't change the result. So same thing, just if it's an equation, it stays an equation. If it's an inequality, it stays an inequality. But this is just basically how we are going to solve inequalities. So if I had something like this, x minus 5 is less than or equal to negative 3. Just like with an equation, if I'm solving for x, I would need to get rid of a minus 5. So I would need to do the opposite of minus 5, which would be plus 5. And we do that to both sides. Just like with an equation, what you do to one side, you have to do the exact same thing to the other side. So you'd have x is less than or equal to 2. And that's your answer for the numeric part of your answer. But then if I wanted to graph my answer, here's what we're going to do to graph your answer. You don't have to count out to 2. I know 2 is not that bad, but you may have answers today that are like 30. You don't want to count out to 30. You can if you want, but you don't have to. All I need you to do is to show me where 0's at, and 2 is somewhere to the right of 0. Okay, that's all I need you to show me. Okay? What I like to do is I like to figure out what kind of dot I need, and then I like to figure out which way we're going to shape. So if it is less than or equal to, that means 2 is part of my solution set. That means we are going to do a close dot at 2. And then to decide whether I'm going to shape left or right, it is less than or equal to 2. Where are the numbers that are less than 2? Smaller than 2. Yeah, to the left. They're over here. So that would be your solution set there. Okay, what if we do x minus 8 is greater than 5? Same steps as solving an equation. To get rid of a minus 8, we would add 8 to both sides. So we have x is greater than 13. Once again, you don't have to count out to 13. Just show me zeros here. 13 is somewhere to the right of 0. Now this time it's just a greater than, not an equal to. 13 is not an option. Okay, x cannot be 13. So to show that, I'm going to do an open dot at 13 this time. And then I want the numbers greater than, bigger than, to the right of 13. So do those numbers right there. Okay, and then we have similar property, except we can use subtraction to solve. So if I have x plus 3 is greater than or equal to negative 4. Okay, to solve for x, I would need to get rid of a plus 3. So we would subtract 3 from both sides. And we should have x is greater than or equal to negative 7. Now this time, you don't have to count out to negative 7, but this time your 0 would be to the right of negative 7, which would be somewhere to the left of 0. Okay, now greater than or equal to, okay, that would be a closed dot here at negative 7, since it can be negative 7. And then the numbers greater than negative 7 or bigger than negative 7 would be these ones over here. Okay, and then the last one of these, let's say we have x plus 1 is less than negative 4. So to get rid of the plus 1, we would subtract 1. We'd have x is less than negative 5. So we'd have 0 somewhere to the left of 0 would be negative 5. Since it's just less than, we would use an open dot. And the numbers less than negative 5 would be the numbers to the left. Okay, so addition and subtraction is pretty straightforward. Okay? Multiplication and division is almost as straightforward, but there's one thing you have to watch out for. And we'll talk about that when we get there. Okay? But same idea as equations. So let's say we have x over 3 is greater than negative 4. Now, just like if this were an equation, when I'm solving for x, I would need to get rid of the over 3, or the divide by 3, which means I would need to do what? Yeah, multiply both sides by 3. Okay, those cancel out. We have x is greater than negative 12. Okay, because I don't need to box that. Okay, so we have our 0, negative 12 somewhere to the left. Since it's just a greater than, not an equal to, negative 12 is not part of my answers. Okay, and then we would shade to the right. Greater than, bigger than, to the right of. Okay, now, x over negative 2 is greater than or equal to negative 4. Okay, this is the big thing, guys. Big thing. Huge concept idea here, okay? Ready? Okay, to solve for x, it's x over negative 2. So to get rid of an over negative 2, what do I do? Multiply by negative 2, okay? Here's the thing. Super important, guys. When I multiply both sides by a negative number, okay? When I multiply both sides by a negative number, you have to flip the inequality sign. This greater than is going to turn into a less than or equal to, okay? You have to flip the sign, okay? And I'll show you, I'll prove to you that you have to. It wouldn't work if you don't, okay? Negative 4 times 2 is negative 8. So the actual answer, the true answer is x is less than or equal to negative 8. So if I were to graph this, 0, negative 8, we have a closed dot, less than or equal to, do these numbers here. So you could pick any number in the shaded area. That's the idea. You can pick any number in the shaded area. Here's all of your answers. Any number here, plug it in, it should work. So like negative 10. That would be a number in my shaded area. If you plug that into your original equation, negative 10 over negative 2, okay, negative 10 over a negative 2 give me a positive 5. Is 5 greater than or equal to negative 4? Wait there, right? 5 greater than? Yeah, that works. Okay? If you had not flipped the sign, watch this. If you had not flipped the sign, you would have gotten almost the exact same answer, but you would have said x is greater than or equal to negative 8, which may not seem like that big of a deal. It's a huge difference. Okay? Because here's the thing. You would have shaded this direction, which would have meant that these were all of your answers. But here's the problem. If I pick any of these numbers, like 0, and I try to plug it into a negative 2, it should be a positive 8, shouldn't it? Look, God, catch me whenever I do these things wrong. Hold on. Back up. Did you catch that? Yeah, why didn't you say something earlier? Okay, just kidding. Okay. First one worked, the second one worked. Okay, so if I multiply by negative 2, that would give me a positive 8. That should work better. Okay, should be a positive 8. You guys can tell me I'm wrong. It happens usually once a year. It's the only, just once a year I think. Usually. So that would be the only time it happens. So, okay, I'm just kidding. I'm making mistakes all the time. Okay, so we have 0, we have 8. Now we have our closed dot shaded to the left. Okay, that should be better. Now my first example did work, okay? If we pick negative 10, which is still in my solution set, it works. But notice when I tried to plug in 0, which is a solution, 0 over negative 2 is 0, and 0 is greater than negative 4. That does work. But if you forgot to flip the sign and had x is greater than 8, then you would have shaded to the right of 8. If I had shaded to the right of 8, what's a number that would have been in that shaded area? Any number to the right of 8. 9. Let's do an even number just because we're dividing by negative 2. It'll be easier. 10. Okay, let's do 10. So 10 would have been in that shaded area. 10 divided by negative 2 is negative 5. Negative 5 greater than or equal to negative 4. And we're in negative world, remember? Negative world is opposite. Is negative 5 greater? It's less than, right? See how this work? If you don't flip the sign, it doesn't work. Okay? Yes. When you multiply by a negative. Notice over here, we didn't have to flip the sign. You could still pick any number here. 0, plug in 0, you get 0 is greater than 1. No problem if you multiply or divide by a positive number. But anytime you multiply or divide by a negative, you have to flip the sign. Okay? Everything else with inequalities is normal. Okay, so we'll see another one of those here in our foldable. Let's try negative 3x is less than negative 9. Okay, so to get rid of the negative 3, it's negative 3 times x. So to get rid of the negative 3, divide by negative 3. We just talked about this, right? I'm dividing both sides by a negative number. Guys, anytime you divide by a negative number, you have to flip that sign around and do it immediately. As soon as you recognize that you're dividing by a negative number, go ahead and write that sign down that you flipped it around. So the x is greater than a positive 3. Okay? And you can always check your answer. That's why it's kind of nice that we have to graph these anyway. We have our 0, our 3. We have an open dot at 3 shaded to the right. And it's nice that we have our answers graphed because it's easier to pick a solution when I can see them, right? I can pick 4, 5, 6, any of those numbers and plug it in, and it should work. Okay? And the last one here, let's do 4x is greater than or equal to negative 12. Okay, so to get rid of the 4, we would divide by 4, and we should have x is greater than or equal to negative 3. Now, this is where you kind of have to be careful because I was taking negative 12 over 4. One of those numbers was a negative, but the number that has to be negative is this one right here, the 4. Okay, the number that you're dividing by both sides, that's the number that has to be negative to flip the sign. I would not flip the sign here. Okay, so we have our 0, our negative 3, we have a closed dot, and shaded to the right. Okay, yes, perfect.
Why did you not shade the middle? Why would you not start the switch with the signs?
Why would I not switch the signs here? Because the only time we switch the sign.
Hey, Anton.
Yes.
Can you send Armando Vito to the main office?
Okay, he's on his way.
Thank you.
Right here when I divided both sides by negative 3, that's when I have to flip the sign. The negative 3 is what's important. Right here, I multiplied both sides by negative 2, and I flipped the sign. Like this first one, I multiplied by a positive 3. I didn't have to flip the sign there. On all these addition and subtraction ones, I didn't flip the sign there either. The only time you flip the sign is when you multiply or divide by a negative number. Okay? And it's just something that it's so hard to remember. And that's probably, honestly, the only hard thing about inequalities, because everything else is the same as an equation. Okay? All right, if you have not done so already, let's get this glued into your notebook. This should be on page 25. And this is 3, 2, 3, 3. One step inequalities. Get your table of contents filled out. All right, let's go ahead and get going with our examples. So we want to solve and graph all of these. So remember to solve, guys, the rules are the same as solving equations. How you do solve them. Addition, subtraction, nothing's different, keep everything the same. Multiplying and dividing by a positive number, keep everything the same, nothing's different. The only huge thing, and it's so big, that you have to remember is anytime you multiply or divide both sides of the inequality by a negative number, you have to flip that side. Okay, that's going to be very important here. Okay, number 1, let's say we have y minus 2 is greater than 11. Y minus 2 is greater than 11. Now, just like with an equation, you first need to find your variable. That's kind of helpful to do. Remember, the whole point here is to get that y all by itself. So I need to get rid of the minus 2. So to get rid of the minus 2, I'm going to add 2. And remember, just like an equation, if I'm going to add 2 to the left, I have to add 2 to the right. So you have y is greater than 13. Now that is your answer, but you want to then graph your answer. So you're going to sketch out your own number line. And guys, it doesn't have to be super spectacular. You get a ruler or anything like that. And if you don't count out to 13, just show me that we've got 0. Somewhere to the right of 0 is 13. Okay, that's all I really care about. Since it's just the numbers greater than 13, not equal to 13, we would use an open dot at 13. And then the numbers greater than 13 would be the numbers to the right of 13. So these are the two things I would be looking for on your answer. Okay, number 2 says 6 is less than p minus 3. Okay, once again, just like an equation, first thing you gotta do is find your variable. Most of the time it's gonna be on the left-hand side, but like this one, it's not, it's over here. So this is what I'm trying to get all by itself. So I need to get rid of the minus 3. So I'm going to add 3 to both sides. So 6 plus 3 would give me 9, which is less than p. Now here's another way where inequalities can get a little tricky. This is your answer. There's nothing wrong with this as far as your answer goes. But why this could be a problem is I need to graph this. And if you haven't picked up on this, when you're graphing, have you noticed how the inequality points what direction you're supposed to shape? Did you notice that? Did you notice that? If you look back at these ones here, okay, see that? Then points this way, shades that way, points left, shades left. You see that? Points right, shades right, points left, shades left. Okay, so that's an easy way to know which way to shade if you're getting kind of confused with the less than, greater than thing. But here's the thing, guys. That only works if the variable is written first. And the variable is not written first here. Okay? And with an equation, it's not really that big of a deal. If I were to solve an equation and get 9 equals p, we could just say, okay, well, p equals 9. Great. Okay? The problem is, an equal sign, there's no difference between the left side of the equal sign and the right side of the equal sign. They're the same. For an inequality, there is a difference here and here. Okay? So you can't just flip it around. You have to, I kind of think about it as kind of like taking a mirror image whenever you flip it. Okay? Or another way you can think about it, see how the open end is towards the p? It should still be towards the p when you write the p first. It should actually say p is greater than 9. Okay? If you write the variable first, then odds are you'll graph it correctly. I'm telling you guys, the people that do not write the variable first graph it incorrectly almost every single time. And it doesn't even take that much extra work to do. So it's a good habit to get into just to write the variable first. So we're going to have an open dot at 9. And now that I wrote the variable first, the number's greater than 9, or look, okay, it's telling me to shade to the right. That only works when the variable's written first. Okay? Alright, number 3. 4x is greater than or equal to 16. Okay, get rid of the 4. We would divide by 4 and get x is greater than or equal to 4. So we have our 0, we have our 4. Now this time, since it's a greater than or equal to, it means that 4 is included in my answer set. So we do a closed dot at 4. And the number's greater than, or notice the arrow is pointing to the right. It would be these numbers here, shaded to the right of 4. Okay, number 4. Negative 4x is greater than or equal to 12. Okay, how would you get rid of the negative 4? Divide by negative 4. Exactly, guys. This is the biggest thing and really the only huge thing you have to watch out for inequalities. I divided both sides by a negative number. You gotta flip that sign. It's gonna turn into a less than. As soon as you recognize that, flip the sign so you don't forget to do it. Okay? So we have x is less than or equal to negative 3. And remember, guys, you can always check your answers. Okay? So if I were to graph this, we'd have a closed dot at negative 3, shaded to the left. If you wanted to check your answer, all you would do is find a number in this shaded area and plug it in. And it should work. Any number in that shaded area, negative 4, negative 5, negative 10, any number in that shaded area should work. Any number outside of the shaded area will not work. Okay? All right, we're going to do 2 more together, and then I'm going to have you try the last 2 on your own. Okay, let's try number 5. Says negative 2 is less than or equal to negative x over 5. Okay, so I'm solving for my x, which is on the right-hand side, what all is over there on that side with the x? The negative and the 5, right? We can get rid of it in the same step, right? What would I do? Multiply by a negative 5. What happens when we multiply or divide both sides of an inequality by a negative number? Flip the sign. So this is going to turn into a greater than or equal to. And negative 5 times negative 2 is a positive 10. Over here, we got rid of the negative and the 5 to just be an x. Now, remember though, here's the problem with this one, okay? When you're ready to graph, you can only follow the sign of the arrow if the variable's written first. And guys, I promise you, I've seen it. I've been a teacher for a long time. As Parker would say, I'm 42 years old. I've been teaching for a long time here, okay? Not 42 years old. I've been not been teaching that long. But I know enough that if you do not rewrite this and put the variable first, I guarantee you will graph it wrong every single time, okay? Rewrite it, get in the habit, write the variable first. When you write the variable first and you flip it around, you have to flip that inequality. Kind of, you're not really flipping the inequality sign, but when you rewrite it, you kind of are, okay? So we know that I should have a closed dot at 10, shaded to the left, because I can follow the arrow. Okay, and number 6. What if I have something that looks like this? Negative 1/3 x is less than 4. Oh my gosh, guys, look! It's a fractional coefficient! You thought that was over, didn't you? How do you get rid of a fractional coefficient? Multiply by the reciprocal, and the reciprocal of a negative 1/3, negative 3/1, which is just negative 3. So we're going to multiply both sides by a negative 3. What happens when you multiply or divide both sides when you multiply by a negative number? You got to flip the sign. Got to flip that sign. So the x is greater than negative 12. So we'd have our 0 and our negative 12. We would have an open dot shaded to the right. Okay, I'm going to give you guys 2 to try on your own. And then you guys can get started on your homework. Okay, number 7. Okay, number 7. Let's do negative x is less than 12. And number 8, negative 13 is greater than 4 plus a. Okay, 7's kind of a tricky one because it's negative x, so it kind of almost looks like it's already solved for, but it's not. How do you get rid of that negative? You can multiply by negative 1. You can divide by negative 1. That's probably what I would do, is divide both sides by negative 1. But when I divide both sides of an inequality by a negative 1, flip the sign. So x is greater than negative 12. So we have our 0 and our negative 12. And open dot shaded to the right. And for number 8, what would I do? Good. Subtract the 4. So you have negative 17 is greater than or equal to 8. Now on this one, what should I do before I graph it? Yeah, I got to rewrite it. So it's going to be a is less than or equal to negative 17. If you don't, almost guarantee you did your graph wrong. So you're going to have your 0, your negative 17. You're going to have a closed dot at negative 17 and shaded to the left.